All right, what's going on, y'all? Today we're going to talk about absolute value transformations. So let's go ahead and get started. If you're not familiar with absolute value, what absolute value does is just basically take a number and it's going to be always positive. So the absolute value of -3, that's just 3. And the absolute value of 3, that's also just 3. You could think of it as the distance the number is away from 0. So that's what absolute value does. You could also think of it as if it's a negative, change it to a positive. All right, so here's the parent function. This is a table. This is what it looks like, and then the domain and range is here. So if you want, you can pause the video and write this down if you haven't already. I'm going to go ahead and do a couple examples, and then that's going to be the whole video. All right, so analyze and graph. All that means is just list the transformations and do whatever you need to. Write the domain and range, and then graph the function. So the transformations in order. So let's go ahead and write HSRV here. So sorry about that. HSRV, so do we have any horizontal shifts? We do not. Do we have any stretches or compressions? We have a vertical stretch of 2. That's this one. It's in the A slot. Do we have any reflections? We do not. Do we have any vertical shifts? We do have down 1. So let's go ahead and write the domain and range. The domain for this is always going to be -infinity to +infinity. You could also say x is an element of the real numbers like this. The range, however, so if you look back at your parent function, normally our range is from 0 to infinity inclusive, right? If we go down 1, however, so you can imagine if this graph, sorry, I know I'm going everywhere. If this graph went down 1, you could actually have a range, your range would also shift down 1 as well. So our range is actually going to be, instead of from 0, it's going to be from -1 to infinity. Alrighty, so let's go ahead and graph this. So here's our parent function. The important thing about graphing this and tabling this is that you want to use as many coordinates as you feel comfortable using. I'm going to use 3 here, but if you feel more comfortable using 5, then that is okay. The important thing about graphing is that you want to make sure that it stays, like the dignity, the essence of the function shouldn't change. For example, I know I'm kind of getting off track here. If you start with this, you should not, it should not look like this at the end. You should still look like an absolute value function. All right. So anyways, I'm going to do the transformations here. The first thing is a vertical stretch of 2. So vertical means y, stretch means multiply. So I'm going to multiply all the y values by 2. So 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2. And now I have down 1. So down 1 means shift the y values down 1, so subtract 1 from all the y values. 2 becomes 1, 0 becomes -1, 2 becomes 1. Let's go ahead and plot this. So we have -1, 1, 0, -1, 1, 1. And remember, it's going to look like an absolute value graph, so it's going to go something like this. Alrighty, so that's the graph of this. Does it look like we stretched it by 2? It does. And did we move it down 1? We did. So it looks great. Let's continue. All right, analyze and graph this one. Ooh, this one's pretty spicy. So the transformations. Let's write HSRV again. Any horizontal shifts? We do. Left 3. Stretchers or compressions? Okay, so we have one in the B slot. This could also be written like -1/2 times x plus 3. So we actually have a horizontal stretch by 2. Remember, things are backwards on the inside, so this is actually a stretch by 2. Do we have any reflections? We do. We have a negative on the inside. That is a reflection over the y-axis. So just ref y. Do we have any vertical shifts? We do not. There's nothing in the K slot. So let's go ahead and here, let's do the domain and range last. It's kind of tricky. So, well, it's not that tricky actually. It'll be fine. So the domain, it's always negative infinity to infinity. Always for absolute value. The range here, do we have anything that's making the graph shift vertically? Is there anything making the graph shift vertically? No, so it's going to be the same, 0 to infinity. Okay, make sure the 0 is inclusive. Now we're going to table. So let's start with our parent function. Now we're going to do this. Remember, you have to do this in order. You have to do this in order. If you don't do this in order, then you're going to get it wrong for sure. So let's go left 3. So left 3 means subtract 3 from all of our x coordinates. So negative 1 becomes negative 4, 0 becomes negative 3, 1 becomes negative 2, and our y values stay the same. Next we have a horizontal stretch by 2. So we're going to multiply all of the x values by 2. So negative 4 becomes negative 8, negative 3 becomes negative 6, and negative 2 becomes negative 4. Lastly, we have a reflection over the y-axis. So that means we're going to change all of the signs of our x coordinates. So negative 8 becomes 8, negative 6 becomes 6, negative 4 becomes 4. Let's go ahead and plot this. So negative 8, 1. So actually I need to add 2 more ticks here. And then we have 6, 0, and 4, 1. So it's going to look something like this. All right, so this one's a bit complicated to check in your head, but if you go through the transformations, think of the parent function, shift it left 3, then stretch it by 2, it should get wider, so as you can see it is wider. Then we're going to reflect the whole thing over the y-axis, and then that's why it's on the positive side. All right, that's going to be it for this video, so hopefully you do well on that homework, and yeah, have a good day.